Right. Very good morning to all the students. So today's class we do continue with our choppers. Right. So just end of the class we'll see the syllabus also. So today's class we discuss different types of choppers. In the external examination, we'll be asking a question: classification of the choppers, or else when you move for the industry also, what are the different types of choppers or classification of choppers. Means many people will mention step up, step down, which is absolutely wrong. So actually the chopper's basic application is step up chopper, boost chopper, or step down buck chopper, or step up down chopper. But in the industrial terms, we say the choppers are classified into Class A chopper, Class B chopper, Class C, Class D, and Class E. So in the question paper also they might use the name Class A or Class B. So today's class, we take all these circuits and we see that every student is perfect in the explanation. So, right. So class A chopper is what, class B, everything we'll discuss. Now what we have to write in the external examination: circuit, simple waveform, and derivation, which you have already done, followed by the graphs. Okay. So now first, Class A chopper. So Class A chopper, another name is step down chopper, which we have already discussed. Or another name is first quadrant chopper. So first I would like to show you the circuit. The circuit already we have discussed with the animation, derivation we have done. Any student tell me what is the output voltage of this step down chopper? Anyone? Output voltage V0 is equal to del or delta or any symbol you can use. Output voltage V0 is equal to del into input voltage Vs or Vi. So step down chopper, this circuit we have seen, and step down chopper, another name is first quadrant chopper. That means output voltage and current will be positive. Power is transferred from source to load. So this class A chopper already we have done, which is nothing but this step down chopper. Okay. Load means here it can be inductive load or whether it is RLE load. The entire waveforms will be same what we have discussed. Now class B chopper. Class B chopper is nothing but the step up chopper or second quadrant chopper. Step up chopper, another name is class B or second quadrant. You can ask, sir, what is the second quadrant? Means the step up chopper, if you see, I just take you to the circuit of the step up chopper. This one also we can show, but this circuit is not the complete one. Okay, if the supply is on here, diode gets turned off. So what is the step up chopper? Already we have taken the circuit. Let us check that circuit. Animation we have seen. So I just take back you to the slide. Yes, I have this circuit, you remember, and we have already discussed the animation of this circuit, step up chopper. Step up chopper, what is another name? Class B or boost chopper or second quadrant chopper. You can ask one question, sir, what are these quadrants? Why we have to use the word? Depending upon the behavior of the motor, if motor is rotating in one direction, that is forward direction, we use it is used in the first quadrant. The second quadrant means the motor is acting as generator. If the motor is moving in reverse direction, that is third quadrant. If the motor is acting as generator and both voltage and current are in reverse direction, then it is also called the generator. We'll see that one. So what is the second first quadrant? First quadrant means if the motor is receiving the power from source to load, then it is represented as the first quadrant and motor is moving in forward direction. If the motor is acting as generator, with voltage is positive and current is negative, then it resembles the second quadrant. This is the imagination. or conclusion of the engineers, civil engineers. So what is a step-up chopper? Why it is called the second quadrant? Why? How you can prove that the motor acts as generator? Means you see. Once again, I will revise. Case 1, what will happen? Anyone? Case 1, the chopper is on. The current flows from Vs plus to inductor, inductor to chopper, and chopper to Vs minus. What is case 2? So what is the case 1? When chopper is on, energy is not transferred from source to load. Now case 2 is what? When the chopper is off, okay, inductor releases the stored energy, it flows through the diode, and now energy is transferred to the load, motor starts to rotate, and from the motor it is transferred back to the source, from source to the inductor. So now we can say energy is transferred from source to load. If the motor back EMF is greater than the supply voltage, what's going to happen here in step-up chopper? If the motor back EMF is greater than the supply voltage, energy will travel from load to which points here? From load to the source. That we'll see here. Okay. So modification of step-up chopper is nothing but the class B. So let us move to that class B circuit. Okay. Now, once again, I am mentioning classification of choppers. It is not mentioned in the syllabus, but still in the external examination JNTU, they will ask you. So class A is 100% step down chopper. Class B is similar to the step up chopper. So what is the explanation of this circuit? Okay, we'll see in detail also animation. Now, what is this circuit? How to explain? This circuit, we have to give the explanation when the chopper is on. Case 1. When the chopper is on and the back EMF of motor is greater than the supply voltage, this circuit operates only at one condition: when the chopper is on and back EMF of the motor is greater than the input voltage. So now here only one statement we can write. Imagine the chopper is under open condition or off condition. When the back EMF is greater than the input voltage, what's going to happen? Energy will be traveling from load to the source. This diode will be on. You can see the current direction. Okay. So this class B, I'll come back. We'll discuss this one. But the challenging circuits are class C, class D, and class E. We completely discussed on this one. So class A chopper is first quadrant, because I will discuss that one. First quadrant, second quadrant, why we are supposed to use. So first we focus today's class C chopper. Okay. So I want every student to be perfect in this class C chopper. Let us discuss this one. Right. Class C, another name is, remember, two quadrant. Class C chopper operates under first quadrant as well as the second quadrant. So let us see what is the circuit of the class C chopper. So any circuit, you must be in a position to give the explanation. So as I mentioned, two quadrant means what here? The motor will act, the machine will act as the motor, and machine will act as the generator also. Regenerative means the word is nothing but generator. When the motor will act as the generator, when we apply the brakes into the electric train. Imagine inside the electric train, we are placing the motor, we are using the chopper circuit. When we apply the brakes, the motor will act as the generator. So what is the statement here? Motoring, more chopper drive for first quadrant. Voltage and current are positive. And you can see this word, armature current reverses. So it will be new for you, difficult to understand right now. But first, our target is explain the class C chopper. Another name for class C chopper is two quadrant chopper. First we discuss the circuit, then you will understand the theory, why we are writing, what is this regenerative, everything. Now, imagine we got one motor. Okay. So we got the motor contains the windings, and in order to create the continuous rotation of the motor, we are supposed to place the external inductor. This is the motor armature resistance. Okay, explain the class C chopper, this explanation we are taking. Now class C chopper contains two choppers, that is two SCRs we can take. A chopper already we have discussed why we are representing in this box, and two diodes. So this is the circuit. So mostly in the industries we go for series motor or separately excited motor. Therefore, if you see in the animation, separately excited motor is taken. Or in the examination, you can just keep here M and you can draw this simple diagram. Now, what is a class C chopper circuit? This is the circuit here. So what is the explanation? First, case 1. All the students be ready. And today morning I have sent first 2 units and third unit material also. But I can confirm that more than the printed material or any textbook, the class listening and writing your own words will make you to get the complete marks. Okay. So listen carefully, put it in your own words. Now, case 1. Anybody can explain the case 1? So there are no inductors and capacitors here in this circuit, and auxiliary thyristors also. Why? Because Jones chopper and Morgan's choppers are the only circuits which contain the commutating components, and remaining circuits we are not showing the commutating components. Actually, if you are designing one new chopper circuit, you must place the choppers and you must show the inductors and capacitors. So, what is the main advantage as per the syllabus point of view? Only the Jones and Morgan's choppers are designed in such a way that they are indicating the presence of commutating components. So here there are no commutating components in this circuit. That's why only the basic operation we have to discuss as per the syllabus. So explain class C chopper. Class C chopper, why the name? What is the advantage? You will see now. Imagine, see in a practical application how we can keep. Imagine electric train has to be started, okay? Or electric car, or even the satellite has to be started. NASA spaceship also. Right? Imagine an electric train has to be started. So what we have to do? How to start that electric train? Supply is on. Turn on one chopper CH1. Then what's going to happen? Direction of the current start from Vs plus to chopper. So you will show in the animation. In order to start the electric train, which is the example of power electronic device, power electronic product. So first, how to start this motor? So when the supply is on, the chopper CH1 is turned on. It is closed. Okay. So motoring mode. We'll see how it is motoring mode. Now you see CH1 is only closed. CH2 is open. Direction of the current starts from Vs plus to CH1. CH1 to it flows through the motor, and motor starts to accelerate, develops kinetic energy and rotates in which direction? Forward direction or clockwise direction. And then the current flows to Vs minus. This is the case 1. Case 1 is what? With case 1, the chopper is on, the direction of the current start from Vs plus to chopper to the load, that is the motor. Motor accelerates, rotates in clockwise direction, develops the kinetic energy, and the current flows from motor to the supply Vs minus. I hope this is understood now. Okay. Any circuit you must write the case 1. Remember the circuit. So if you want the practical explanation, imagine when electric train has to be started. Electric train will be started with the chopper 1 on condition and the direction of the current flows as shown. Okay, from Vs plus to chopper 1 to motor, and from motor to Vs minus. Motor rotates, accelerates and develops the kinetic energy. Case 1 is done. Now again in case 1, here we are having the inductor. Why we are placing the inductor? It provides the continuous current. Okay. Now what is the main advantage here? Imagine the electric train is approaching one station. Electric train has to be stopped. Electric train speed has to be decreased. Therefore, what we do here, now after a certain period of time, chopper 1 is turned off with the help of forced computation circuit. Chopper 1 is turned off. Then energy stored by the inductor is responsible to rotate this motor in which direction? Same direction. So what's going to happen when electric train is approaching one station? The inductor releases its stored energy and it drives or runs the motor in the same direction. In this condition, we are not applying any supply. Now you can see here. So what is the case 1? When the chopper 1 is on, direction of current start from Vs plus to Ch1 to the motor, okay, from motor to Vs minus. During this process, inductor energizes. So during this process, inductor energizes. So this will be positive and this will be negative. Now after certain period of time, when the chopper 1 is turned off, you can see now it is the first condition. Now chopper 1 will be off. You can check in the animation. This the inductor is energizing now. So clearly you must understand. Okay, case 1 first condition. Yes, now you can see chopper 1 is turned off. Why we have to turn off the chopper 1? Because electric train has to approach the nearby station. Its speed has to be decreased. So what we do, we turn off the chopper 1, therefore supply is disconnected to this motor, but still motor rotates in the same direction, in the forward direction, because of the energy released by the inductor. So what is the case 1? Next part. When the chopper 1 is off after certain period of time, the energy stored by the inductor is released, is de-energized, and the de-energized current will drive the motor in the same direction. Therefore, current flows from L plus. See, when inductor is energizing, this upper part will be positive and here it will be negative. Now, inductor is de-energizing. So, here it will be plus and this upper part will be minus. Okay, for inductor, it gets reversed, the terminals. So, what is the direction of the current? L plus to motor to diode D1, and from diode D1 to again L. RA you can also mention. So what is the direction of the current again in case 1? L plus to motor. You can ask one question, sir. Here the condition is inductor voltage is greater than the back EMF. That's why energy is traveling from inductor to the motor. So L plus to motor to diode, freely wheeling diode. Okay, we already know. Diode to the again L minus. Understood now? What is case 1? When the chopper 1 is on, direction of the current starts from Vs plus, it flows through the chopper 1 and then to the motor, from motor to the Vs minus. Chopper 2 is off, we are not giving any supply. And after certain period of time, the chopper 1 is turned off, then inductor releases the stored energy. The direction of the inductor current is given by L plus to motor to diode D1, and from D1 to the L minus. So in this way, the motor also rotates in the absence of the supply with with a decreased speed before approaching the station. Right. So now what's going to happen? I want to stop the electric train. Now we are moving to the case 2. So this is called the case 1 is all about motoring mode, the name. So motoring means that it is moving in forward direction. Now we go for the case 2. Okay. Case 2, regenerative mode. Regenerative means energy from the motor or from the load, it transferred back to the source. That is the word called regenerative mode or generating mode. When the motor will act as generator, all students, this point is important. A machine acts as a motor if its back EMF is less than the supply voltage. A machine acts as the generator if its back EMF is greater than the supply voltage. Simple word you can keep. Okay. A machine acts as the motor if its back EMF is less than the supply voltage. A machine acts as the generator if its back EMF is greater than the supply voltage. So what is the next case? Case 2, regenerative mode or generating mode. So now what is our assumption? Assumption is now this back EMF of this motor is greater than the supply voltage. Now this motor will act as the generator. So when I have to use this, when I have to make this motor to act as generator, whenever electric train has to be stopped. Case 1 is what? When electric train has to be started, we use the chopper 1 and we rotate the motor. Now electric train has to be stopped. You can say, sir, directly we can stop the electric train. Okay, but what is the greatness of power electronics subject is, whenever an electric train is stopped, during that condition also, the motor can be able to act as generator and it generates the electricity. That power is again fed back to the source. That means if I want to stop one electric train, immediately the electric train will never stop suddenly. It takes certain time, it moves forward and then it slows down and then it will stop. So during this process, the motor will be acting as the generator. Understood all of you? So the explanation what we are discussing, it is far beyond the textbook explanation. So first circuit it will be tough, but you will be in a situation you can compare with the even university students. You will be in advanced mode explanation. Okay, right. So case 2 is all about generating mode or regenerative mode, where when electric train has to be stopped, the back EMF of the machine is greater than the supply voltage. Therefore, the motor will act as generator and energy is transferred from motor to the now it is generated from generator to the source. So now how it will happen? During this condition, the back EMF is greater than inductor voltage and back EMF is greater than the supply. Therefore, direction of the current starts from the plus terminal of the motor. You can see here they have given here plus and minus. Positive terminal of the motor. So we can use the word generator. So G plus to inductor, and from inductor to where it has to go first? First inductor has to energize once again. When motor is acting as generator, energy first travels from generator to inductor and inductor to now chopper 2 is on and then the current flows through the motor. So we'll see the animation. Case 2. Chopper 1 is off. Okay, this is inductor releasing the energy. Just now what we have discussed. Inductor releasing the energy. Already we have discussed that one. And motor is rotating. But now case 2 we are discussing. Now you see, this is still inductor de-energizing animation. Yes, as I mentioned, regenerative braking mode. When you apply the brakes to the electric train, the motor will act as the generator. Remember this point. Now, what is a case 2? Regenerative braking mode or generating mode. When the back EMF of motor is greater than the supply voltage, the motor will act as generator and energy is transferred from load to the source. During this condition, the chopper 2 is on and chopper 1 is off. So how the current flows? So first, from the motor, current flows to the inductor to the chopper 2 and get back to the motor. Okay, motor or generator mechanism. First, you can see the direction of the current we have to indicate. You can see now. Now, due to this, the inductor once again gets energized, re-energized, okay, because of the motor. Okay, inductor is energized. Now, case 2, what we have discussed, if the back EMF of motor is greater than the supply voltage, the motor will act as generator and energy is transferred from load to the source. Okay, that point also we are going to write. But here, what is the direction of the current? From G plus or M plus, G plus to inductor to chopper 2 and chopper 2 to G minus. And at the same time, remaining amount of current will flow through D2. You can see this point, this junction here. So what is the explanation? Certain amount of current will flow through the CH2. At the same time, remaining amount of current will flow through D2 and from D2 to the source, and source voltage is less than the back EMF. Therefore, energy current flows from high level to low level, high voltage level to low voltage level. Therefore, remaining amount of current flows through D2 to source and from source to the motor. Now we can say that energy from the load is transferred back to the source. You can see that animation now. So certain amount of current flows in this direction. In the examination, one more circuit you have to draw and you have to show. Now you will see under regenerative braking mode. You can see now remaining amount of current, you can see it will be off. It will flow from generator to inductor to diode D2, from diode D2 to the source, from source to the entire generator. Very tough circuit and explanation will be new. Now we can say it acts as a generator because voltage is current, voltage is positive and current direction is reverse. There is no word called negative current. Okay, If the direction of the current is reversed, we represent here by minus IA. If it is plus IA, it is nothing but machine is acting as the motor. So case 2, I am going to repeat once again. If the back EMF of the motor is greater than the supply voltage, then the motor acts as the generator. Energy is transferred from energy is transferred from load to the source. So first, energy travels from generator G plus to inductor, inductor to the CH2, CH2 to the G minus. Okay, G means here we are assuming it is acting as the generator. Remaining amount of current flows from G plus to inductor, inductor to the D2, D2 to the source Vs, and from Vs to the G minus. So this is the proof that this class C chopper acts as the generator also. Therefore, it acts as motor and it acts as the generator. It operates in how many quadrants as per the engineer's knowledge? 2 quadrants. First quadrant, voltage current positive, motor. Second quadrant, voltage positive, current negative, generator. You can see CH2 and D2. It is acting as the generator. I hope all students understood this one. Examination, you have to explain 2 to 3 circuits. Okay, right. So this explanation is done. We take right. Based upon your requirement, I will proceed once again. Come on. So now you will be understanding. Motoring mode, chopper drive offers first quadrant because armature current and voltage remain positive. Next, which mode here? Regenerative braking means when you apply the braking condition, back EMF of the motor will be greater than the supply voltage. Now the motor will act as a generator and power flows from generator to the source. Armature current is reversed. So our language is only circuit. That's why it operates in 2 quadrants. First 2 quadrants. So we are having the motor. Shall I repeat all of you, or it is okay the explanation? Anyone please confirm? Shall I explain once again this one? Type C. Yes, in the chat box or unmute and please tell me. These are most important circuits and toughest one. Huh? Understood or not?
Understood, sir.
Right, good. Okay. So now we move to the next type of chopper. As I mentioned, okay, right, thank you. As I mentioned, we are having class A step down, class B is similar to step up. What is the class B explanation now? Anyone can tell. What is a class B chopper? Class B chopper is only second quadrant and class C chopper is first quadrant and second quadrant. Now you tell anyone what is the operation of this circuit? Chopper is off and back EMF of the motor is greater than the source voltage. Energy travels from back EMF to inductor, inductor to diode, diode to the source, and from source to the back EMF minus point. Only one line explanation. So class C chopper is a combination of class A and class B. Just now what we have discussed. So now we move to the class D chopper. Okay, right. I hope now we are moving to the class D, all of you. I want the explanation. This is also 2 quadrant chopper. 2 quadrant. It operates in first quadrant and fourth quadrant. Okay. Anyone come on? Who will explain this circuit? So load means motor only. First, I want to rotate this motor. How to rotate this motor? First, chopper CH1 should be on. You see all of you, case 1. Case 1, CH1 is on and load is also connected to CH2. Therefore, CH2 is also on. So, case 1 is CH1 and CH2 are on. Okay. Now, when the supply is on, direction of the current start from VDC plus to chopper 1 and from chopper to inductor. Inductor energizes and from inductor to the motor, motor to chopper 2 and from chopper 2 to VDC minus. Is it clear all of you? Now during this condition, motor accelerates, develops kinetic energy and rotates in forward direction. That's okay. Okay, when the supply is on with chopper 1 and chopper 2 under on condition, direction of the current starts from VDC plus to CH1 to inductor, inductor energizes, inductor to the load, that is motor, motor starts to rotate, and next from the motor to the chopper 2, from chopper 2 to the VDC minus. It is done. Okay, motor is rotating. Now what will happen under case 2? Okay, case 2 is when both the choppers are off. I want to make this particular motor to act as generator. What we are saying, motor to act as generator. What we have to do now, when it will act as generator, when the back EMF of the motor is greater than the input voltage, the motor will act as the generator. Same explanation. When the back EMF, case 2 is which mode? Generating mode or motoring mode? Generating mode. Okay. Case 1 is motoring mode. Case 2 is generating mode or regenerating mode. Okay, right. Case 2. When the motor back EMF is greater than the source voltage, then the motor acts as generator and energy is transferred from motor to the source, or from generator to the source, or from load to the source. So under case 2, both choppers CH1 and CH2 are turned off. When they are turned off, energy direction of the current starts from the load because it is acting as generator. Therefore, what is the direction of the current? That is the load, means here we can write from load to D2, D2 to, already it is of source, and from source to D1, D1 to inductor, inductor to the load. Is it clear, all of you? So case 2 is what? Generating mode. When the motor back EMF is greater than the supply voltage, this motor acts as the generator. It generates electricity. So how that electricity is transferred back to the source? From load to D2, D2 dash load dash D2, D2 dash VDC source, VDC dash D1, and from D1 to inductor L, L to the load minus terminal. So load plus to D2, and at last receiving to the load minus. That's all. So case 1 it acts as the generator, case 1 it acts as motor, case 2 it acts as the generator. So this is class D. So for your understanding of the nodes, I've just mentioned, see case 1, both choppers are on, yes or no? And this will be the circuit. Examination also you can draw the same circuit. From supply to the chopper, inductor energizes. And what is the case 2? You can see inductor is de-energizing, yes or no? Here it is energizing, de-energizing means the supply terminals gets reverse potential. So from the load to D2, D2 to source, and from source to D1, D1 to the inductor. So now what are the graphs here? Already we have taken this particular graph. So first chopper is off. Yes, sir. IG1, IG2 means chopper 1 and chopper 2 currents. You can see first IG, that is chopper 1 is off. When chopper 1 is off, inductor is de-energizing. Yes or no? And when the chopper 2 is on, inductor is energized. So this graph is not required actually. So you can show the graph. So now we just take within 2 minutes. Tomorrow, next class will be the problems. Class E. You can see this is the new huge circuit we are having, but already we have started the class E topic, class E circuit. So I'll explain that class E now. On the day, only off circuit we have taken. I hope you people remember 4 quadrant chopper, right? So what is class A? Class A is first quadrant. Class B is second quadrant. Class C is what? First and second quadrant. Class D is first and fourth quadrant. And class E is nothing but 4 quadrant chopper. So 4 quadrants we should operate the motor. So all the cases we take it. Already we have taken this circuit. I am explaining. All students unmute yourself and get ready for this question. Come on. So let us draw the circuit completely. I hope you remember this one I have taken. Now today we are going to finish this one. Explain class C chopper or 4 quadrant chopper. So dual converter also will act as the 4 quadrant. A chopper circuit also will act as the 4 quadrant. Here the explanation with respect to the 4 quadrant. So which is 4 quadrant chopper? Class C. Objective types for internal 1. 4-quadrant chopper is class C. 2-quadrant chopper is class C and class D. Second quadrant is class B, and first quadrant is class A. Anyone come on explain this circuit? I'll see. Who is ready? Yes, case 1. We are starting the case 1, right? Case 1 is what? When the chopper CH1 and CH4 are on, direction of the current start from Vs plus to CH1, CH1 to the inductor, inductor to the motor, and from motor to CH4, CH4 to the V minus. Is it clear, all of you? I'll make it very fast now because already this one is understood. We have discussed. When the supply is on, case 1 I am repeating, when the supply is on with CH1, CH4 are under on condition, the direction of current start from Vs plus to CH1, CH1 to inductor, inductor to motor, motor to CH4, CH4 to the Vs minus. During this process, inductor energizes and motor accelerates and gains kinetic energy, rotates in forward direction. Okay. Now, after a certain period of time, inductor starts to de-energize. When inductor de-energizes, what's going to happen? You can see here, CH1 is off, but CH2, CH4 is on. CH4 is on. Therefore, how the inductor will de-energize? I'll show you the animation here. Yes. Now, case 1 only. This we have discussed. CH1 is off, inductor is de-energizing now, you can see. And it is making the motor to rotate in same direction with CH4 on condition. That current starts from inductor, inductor to CH4, CH4 to D2, D2 to the L minus. Now, with the help of inductor, the motor rotates in same direction in the absence of this supply. Already this part we have done. I hope it is clear. Direction of current you have to write L plus to motor, motor to CH4, CH4 to D2, D2 to the L minus. Now case 2 we are going now. Okay. Now, okay, case 1 only. After certain period of time, if the back EMF is greater than the supply voltage, then this machine will act as the generator. Electricity is generated from this generator and it flows back to the source. How it will be done, we'll see in the next class. Okay. Last 1 minute is only there. So I'll take the attendance screenshot.
Excuse me, sir.
చెప్పండి.
Sir, are we going to have two exams?
వాయిస్ బ్రేక్ అవుతుంది, చెప్పండి. హలో.
Are we going to have two regular exams, sir?
Regular exams from November month, I think, right?